Okay, so one of the things that we need to look very directly at this week is kind of our understanding of constraints. This week we have a really fun little rig and animation that we're going to be creating. If you go over to Canvas, let's just start the day by exploring what we're going to be talking about in Canvas. So in the week 2 module, I started to publish a whole bunch of information. Hopefully everyone's rounding out their animated chain that was due today. So if you're not done with it, you got to be done with it. Okay, we need to be finished with that very, very quickly because we need to move on to bigger and better things. Specifically, the Catapult rig and render. This is going to be our first kind of more advanced rig. And the goal for this assignment is to take a simple model, which I provide, and to create a fun little animation from it. Okay. Now, as you look as my catapult rolls in, there's a couple details in here that we need to be very mindful of. Okay. Let's make it go full screen. Here we go. Let's play it again. Now look at the catapult as it rolls in. What do you see happening that we should be mindful of?
The wheels are spinning.
Yeah, so the wheels are spinning, right? It's not just like floating through the entire environment. The wheels are spinning, and more directly, you'll see this in action here in a second, the wheels are spinning to match the translation of the object, or the distance that this object travels inside of the space. So it's not like we're not hand animating the wheels. The wheels are automatically spinning based on how far the catapult moves inside of our scene. That's good. You want that, right? Yeah.
So in terms of movement for the catapult, like when the hand or arm, is it called?
Yeah.
When it launches, it slightly moves backwards. Would that count?
I like it, absolutely. Yeah, so there is some secondary motion that we should include in our animation for sure. But as far as the rig's concerned, what else did you see? And Tom, you were right there talking about it. So what else are we going to animate here? The arm. Okay, so we need to create a mechanism for the arm to fire some sort of boulder, right? Maybe I need to go back and like re-render this with like flaming clay pot. I always love that from like, from history, how they did like siege warfare. Let's take it entire. It's just such a guy moment, right? It's like, how are we gonna burn down this building? I know, clay pots of oil. Let's set it on fire and launch it at people, right? It's just, right? Such a dude moment, right? Let's any opportunity we have to burn something, we're gonna do it, right? It's just how we operate. It's so strange. My wife, like, fundamentally does not understand 4th of July. It's like, so let me get this straight. You're gonna spend $100 on fireworks, right? That you are going to burn in 10 minutes. Yeah, exactly. The natural thing is you're literally burning money. Yep, don't do it. Anyway, all right. So we have a couple of goals in here that we need to strive to achieve when it comes to the rig. And I think this is a really important place to begin our conversation today. Is that as animators or as riggers, what we need to do is understand what our animators are going to be doing, right? Because remember, there are no super rigs, right? There's not a mega rig that will do all things. We have to purpose build our rigs for the purpose of the animation, right? Usually, how do you think this happens? How does this
probably
start?
A lot of back and forth communication between the rigging departments and the animation departments.
Bingo, right?
The riggers have to know exactly what the final product is supposed to be, or they can.
Absolutely. This is a great example of where this is not an individual process. The animation is a team sport, and the riggers, the articulators, have to talk very directly either with the director, the animation supervisor, the animator that's going to be doing the shot, and they have to say, what do you need, right? Because I'm only going to build what you need, right? Do you want the wheels to turn? Got it. Okay. Do you want to have the arm fly up? Okay. That answers that. Yeah. Okay. I'll make the arm fly up. No problem, right? We don't put more in the rigs than what we need them to do, right? There are no super rigs. Okay. They're purpose built. So we need to have a direct conversation with our production team to get us going where we need to go. All righty. Let's keep cruising here.
You said something about the wheels moving automatically in tandem with the rest of the catapult.
Uh-huh.
Is that going to be? Is there a way that you're going to show us how to make that happen without like specifically doing it? Because you said we're not going to
Yeah.
be animating the wheels frame by frame, so
No.
there's going to be a way to like sync it up.
Absolutely, and it's pretty ingenious. You guys are going to love the motor rigging system. In every sense, we're going to take a gigantic step into the motor rigging system this week. Okay? Yeah, it is. This is where the evil laughs begins to begin. Because it said, you know, think of it like this: we get to build the machines. That's really what an animation rig is. It is a little engineered machine inside of a cool 3D model. Yeah.
Question: do we have to add something for the Catapult to throw?
No. I mean, I'm not going to say no. Yeah, absolutely. Yeah, you don't have to. You don't have to. Yeah, like I said, the focus of this is the rig, and we're going to continue kind of galvanizing and strengthening our rendering skills. Okay. Almost every single project we do in here is going to be animated and rendered to some degree. Okay. It's important that we are always going through the entire pipeline. We can't be entirely laser focused on just one part of it, because then we lose sight of all the other stuff. Okay. Dawned on me for a second that, okay, maybe now, yeah, great. So let's do this. What we're going to start off with is, let's open up Modo, and let's get to work. Yeah, so like on my screen, they don't have Modo on here, so let's launch it using the quick search. Our conversation today is going to center and focus around the role and the impact of constraints. Now, we saw a little bit of these constraints in action last week. What was the name of the simple relationship that we made last week between all of our chain links? Parent-child. That's the most simple explanation, or the most simple relationship that we can create. Today, we're going to take another gigantic leap forward into our understanding of the motor rigging system. Give me 2 seconds. I'm just going to change a couple things to make it a little bit easier for you guys to see what we got going on. Okay, so here's what I'm going to do. I'm going to simply create, just in the model tab here, a donut, a circle, okay, a ring. Now I'm going to make 2 of them, actually. What I'll do, and with that polygon selected, of course I'm going to center it. Because we always, whenever we're generating model geometry, it's important for the entire rigging sequence that this geometry be centered at the origin of our scene. Last week when we were working with pivot points, where was the location of all of our pivot points initially? Not so much at the geometry. More specifically, where was it? At the origin. And our geometry just happened to be at that exact same spot, right? The origin continues to be a major influencer on on our entire animation pipeline. All right, so here's what I want to make it kind of like a little ring. So I'm in my polygon selection set, and I'm simply just going to bevel this guy down. Something like, I don't know, something like that. I want to do a couple more of these bevels, so I'll do Shift, click, something like this. There we go. Now what this has given me, some areas to delete. Okay. Now I'm going to extrude these out and make them three-dimensional shapes. Okay. When I extruded this out, however, I moved these back faces away from the origin. So with everything selected, excuse me, with everything selected, I'm going to center it again on the z-axis. Okay, now we're dialed. Okay, I want to be a mega nerd here, because I can't not be. This is going to drive me crazy. Okay. All right, well, that'll do. No, it won't. All right, there it is. Okay, now I can breathe a little bit easier. Okay, so let's give it some good materials, because I like to separate things out with color. And I think I'm going to have this guy and this guy be different. So let's do this. We'll make this one red. And I'll make its surface color red. There we go. And I hit cancel. Okay. We'll make this guy blue. There we go. Now it's blue. All right, there we go. So we got a big red ring and a gigantic blue ring. Now I want to be able to animate each one of these separately. So what's the next step in this?
Separate them out. You have to separate them out.
Into what?
Different meshes.
You got it. They have to be in their own items, right? Because remember, in Modo, we are in an item-level animation system, so everything that needs to move independently needs to be separated out onto its own item. So how can I do that quickly?
Yeah.
Hit the N key, which is going to do what?
Separate this one. Open up another mesh.
You got it. So it's going to physically create a new empty mesh item. Now, when we compare mesh to mesh 2, how do I know that mesh 2 is in fact empty?
Grayed out.
Yeah, it's grayed out. You know, I like that. It's a nice little visual reinforcer that there ain't nothing in here. Okay? So, I'm going to select my blue polygons, edit, cut, and then go to my mesh 2 item and do edit, paste. Okay, now I've separated them out. Let's get a little bit more direct here, because red ring. There we go. All right, so I got my red ring and I got my blue ring. We're done. That's the conclusion of the modeling that we're going to do for the next couple minutes. All right. So we're going to be spending the rest of our time today in the Setup tab. Okay. The Setup tab, it's right here. The Setup tab is going to be our new home away from home when it comes to all of the rigging stuff. We didn't really go into this in great detail last week, but really the Setup environment is where Modo exposes all of its rigging tools. Let's cruise over to Setup. You're going to find that this environment is not too dissimilar. However, there's a new thing inside the Setup tab, or there could be a new thing in the Setup tab that you've never seen before, and that's this bottom part down here. Does anyone know what this is called? Gray. This is called My Brain Hurts, right? This is the schematic layout, or the schematic window, excuse me. This is where we're going to nodally place all of these, or make connections between all of these different items, okay? Let me see, hold on one second. I want to see on my computer here. I don't know if it's been loaded. Let's do content folder. There used to be a really great rig. I'm not sure if it's in here anymore. I think it's just simply called Ball Man. No, okay, cool. Well, let's open up one of these other guys. Let's do Dancing Plant. Okay, so I really don't know what this dancing plant is. It's a dancing plant. Awesome. You can't go wrong with the dancing plant, right? However, if we start looking at the schematic, you can start to see how we can make all this stuff work. Okay, this is what a nodal rigging environment looks like. We have a whole series of inputs that then get fed into certain little bundles of code, if you will, and that information is then sent, to and from all these different little code snippets and these nodes. Okay, this is both the awesome part and not awesome part about working inside of Modo, right? Because this can turn into a wickedly powerful, and I mean a very, very, very powerful rigging system, but it definitely has some learning curves associated with it. Okay. So let's stop my dancing plant and jump back over into our environment. Okay, the red ring and the blue ring. Now, if you don't see your schematic, this part down here, okay, one of two things has happened, and this is likely the scenario. Someone before you has maximized the top viewport, okay? Your schematic is always there, okay? Just by doing that, you can make the top viewport, or any viewport for that matter, large or small. It dominates that center viewport. We're not going to necessarily need the schematic at the moment. The latter half of today's class, we're absolutely going to need the schematic. So we're gonna just kind of minimize it for the time being and focus back in on our red ring and on our blue ring. I'm going to customize my viewport just a second here. Turn off my trackball rotation. Oh, here's you guys are advanced users. Let me show you a really great trick. This is something I do on my home workstation. I forget to do it here because our config files are replaced almost every single night. But there's a master switch for toggling the trackball rotation. If you want every single viewport to not have trackball rotation, there's a master switch. And you can find it in the motor preferences. And I believe it's under the OpenGL section. It is not under the OpenGL section. Oh, I'm horrible with lists. But there is something in here. Application, UI. No, it's in here somewhere. I would have sworn it was in OpenGL. Well, let's see. I'm not going to spend much time in it. It's under the remapping section. I don't know why it's under remapping, but it's in the remapping section of your motor preferences, and it's right there. You can turn it off, and then what I do is I override viewport level and trackball rotation. Okay, so with it off and this on, it's basically we've turned it off on every single viewport in the application. Okay, so now let's test it real fast. If I was to go over to the render environment, yeah, I'm not getting the trackball rotation down here anymore. Okay, cool. This is a power user tip for today. All right, I'm also going to turn off my grids real fast. It makes it easier to see when all of our grids are off. Okay. All right, so let's get to work here. Now, what I want to have is that I want to have a relationship be generated from both or between these two different items. Now, last week what we did is that we created a parent-child relationship. Now, describe to me really the function of a parent-child relationship.
Take one piece of it into one part and take one mesh and put it into the other.
Okay, good. That's how we do it. But what's the purpose behind it? What's it going to do? You got it. Absolutely. So where the parent goes, the child is also going to go. It's as if we're overriding the transform channels of the child and kind of dragging things around the scene. Now, Thomas, how did we create that parent-child relationship?
By dragging them into each other.
You got it. And this is the easiest way to do this, right? Over here in the item list, just drag and drop. Bloop. We create a simple little hierarchy. This is the parent. This is the child. Follow the dotted lines. Okay, it's just like working with nested folders on your computer. So if I was to grab the red guy now, and wherever it goes, the blue guy's going to go along for the ride. Rotate it, shoot even the scale. It really is a modification of all the transforms. Okay, which is pretty neat. All right. So that's what we did last week. But you know, if you think about it, the parent-child relationship, it is overriding the entirety, and I mean the entirety of all the transform channels. The blue ring is now adopting the translation, position, rotation, and scale of the parent. Well, what if I wanted to break those out individually? What if I only wanted to have the parent, okay, this guy, influence the rotation, okay? I don't want the blue thing to move. I just want it to rotate with this guy. We'll see how that works, okay? And this is where the role of constraints come in, that we can kind of start to unhook our transform channels and start to individually make meaningful connections between two different items and specific transform channels in our items, okay? So let's do it real fast. I'm going to unparent my blue guy from my red guy just by dragging it out of the hierarchy. There we go. So we're back to normal. And now let's start making these relationships. And it's really easy to do this, and it brings us to all of our rigging tools, okay? Now, like the modeling interface, the setup layout, has a whole series of vertical tabs on its toolbars that's going to expose different workflows and different tool sets to the user. So here we got the setup tab, setup tools, command regions, modifiers, inverse kinematics. This is where you're going to find all of your dynamics and particle tools. It's all found inside of the setup tab, okay? So prepare yourself for, kind of get used to and comfortable for coming in here, all right? Here's all of our particle tools. Now what we're looking for is under the modifiers section, okay? Now inside the modifiers, there's a whole bunch of constraints. Here they all are. But what is the one thing that you're seeing is unavailable to us at the moment? What do you see? They're all grayed out, right? They're unavailable. They're not available for us to, apply to our different items inside the scene, okay? Now, there's a whole bunch of them. Let's simply start off and do position, okay? So, unlike the parent-child relationship, now we're going to link just a certain, just the position channels of these two items together. And we have to follow a very, very direct, selection system. And here's how I kind of make it work in my brain, okay? I select the parent first, child second, okay? In my mind, I want this guy is going to get constrained to that guy. Actually, I had it backwards. I'm sorry. The child is selected first. The parent is selected second. So I want to constrain this to that, okay? So with that selection order in tow, if I do position, on the surface, it seems like nothing happens, right? However, if I move this guy now, they both move. Again, on the surface, this seems magically identical to what we had in the parent-child relationship, but watch what happens when I rotate. What doesn't happen? Yeah, the blue ring doesn't rotate, okay? Because we're just modifying the position channels between these two different items. The parent-child relationship is going to do all three simultaneously, right? It's going to override the position, rotation, and scale. But these individual modifiers over here will allow us to separate those out and only make connections between the channels that we want connections to be on, right? So that's the position modifier. Before we go any further in this, I'm just going to go back in time a couple steps, okay? So here we are. The constraint has been applied. Let's look underneath the hood here a little bit and start getting a little bit more of an understanding as to what's going on, okay? Now, in the viewport, you really don't get any sort of understanding that there's a relationship between these two different items. To really get a granular sense of what's going on, we have to go over to the item list, okay? The item list is going to be our master tree view. It's going to show us all the details of all the different items that are influencing our scene as a whole. A couple things have changed now that we've added in that constraint, that position constraint. Does anyone see it? Yeah, check it out. There's a little plus sign over here. And there it is. Okay? That's the actual constraint. Okay? Constraints are always going to be found on the object, on the child object, if you will. Okay? You can name these. Some people have very intricate naming conventions for their constraints. If you work in very large scenes, this can be helpful. I'm not going to go into too much on the naming convention for constraints, but people do change them, okay, and you're welcome to change them. I like, at the very least, abbreviations go a long way, okay. So I do like oops. Hold on a sec. Moto's deciding it wants to crash. Yeah. Awesome. Thanks, Moto. Appreciate it. Let's try that again. So you're more than welcome to go in and change the name of your constraints. I think at the very least it's a good practice to abbreviate them a little bit. They can get quite long. And if you have long item, let's see, autosave, save my bacon. At the very least I don't have to rebuild my scene anymore. Although I restored the master config, so all my trackball rotation stuff is gone. At least I know where it is now. There it is. All right. No, I don't want to do. There we go. They were trying to do a bug reporter on me, and I don't want to do a bug reporter. Okay. So let's make the relationship one more time. Okay. Here. I'm going to save my files real fast in case there's another crash. All right. So if I wanted to constrain the blue ring to the red one, which one of these do I have to select on first? The blue ring. This, I'm holding down shift now, gets constrained to that. And for whatever reason, in my mind, the this to that workflow just kind of resonates with me. It's something simple for my little brain to hang on to. With those two things selected, my position constraints are now available. Okay, so let's fire it off. Constrain these two items together. We can see the constraint over here in our item list. There it is. I'm not going to rename it. And the naming conventions for your constraints actually have a much larger role when we're working in very complex scenes. During the break, I'll see if I can find the ball man rig that I was mentioning earlier, because you will see very directly, and I mean very directly, how complex one of these character rigs can get. The reason I bring this to your attention is that often the easiest way to find one of your constraints, to modify them in one capacity, is to not drill down to the actual item. Because in complex rigs, it's going to be very difficult to find the actual item itself. It's going to be nested in this huge hierarchy of folders and what have you. The easiest place to get to it is at the scene level. See how we have a little plus sign up here? It also shows all. This is going to give you a master list of all the constraints that are currently operating inside of your scene. This is where that naming convention really kind of comes into play. Okay? So two different ways to get to your constraints. Now we talked about adding constraints. How do I delete a constraint? Huh? You got it. It's really as simple as just going blunk and it's gone. Okay? You can right click on it. Yeah, you probably can do it on the keyboard. I'm not Mr. Keyboard guy when it comes to this stuff, okay? But you can delete the constraints pretty easily, okay? Constraints have a series of options and properties. We'll get into some of those here in a minute. But there's a lot going on underneath the hood that influences very directly the objects in our scene, okay? All right, so that's what the position constraint does. Let's take this up a notch here a little bit, okay? Because there are a whole bunch of them that we want to look at. And the next one that we want to do, same selection order. Let's do rotation. Because rotation is where it gets really fun. Okay? Because rotation now, of course, if I was to simply move my red ring, what do you think is going to happen to my blue ring if I move it? It's going to stay there, right? Nothing happens when I move it. Okay? However, if I start to rotate it, they all move. Okay? So again, we're unlinking our transform channels from each other. And now we're individualizing the relationships between each one of these items. Okay. So that's all well and good. That's pretty cool. I think that's a lot of fun. Okay. I'm going to go back over here to my my properties, and I'm simply going to put that at 0, which should put the ring back at the origin, and it does. I think at one point I moved the blue guy. Let's put that at 0. So now they're all lined back up. Now this relationship is pretty neat, but let's modify this a little bit. Let's kick this up a notch. And let's start bringing the schematic workflow into our rigging environment. Because the schematic for us is going to be a big part of our workflow. Okay? Let's pretend that I rig this and my animator then comes to me and says, Pat, you've done a stellar job, but here's exactly what I need, okay? When I rotate the red ring, I want the blue ring to rotate in the opposite direction. how am I going to do that, right? Interesting challenge. Luckily for us, the schematic workflow allows us to very quickly make those changes to our rig. So let's bring the schematic back into play. Please remember, I'm just hitting this little button here to maximize and minimize that top viewport. And now you can see the schematic downstairs. Now I want to start loading and populating the schematic with the items that I want to continue to work and manipulate. So in every sense, I need to get a kind of representation of all of the items in my scene down here. Has anyone explored and stumbled on how we can do this easily? Drag and drop. It really is quite wonderful. So I'm going to drag, in this case, I'm going to start off with the red ring. I'm going to drag it from the item list down here into the schematic. And now you can see we have a little node down here waiting for us. Okay? It's always going to give us the name of the item. The icons are going to be the same. They've done a really great job of making it very clean and very easy. However, once we deselect it and get rid of that orange border, there's a little yellow dot there, okay? Let's talk about that for a second. You see the little dot on either side? Think of these like little terminals. This is the input terminal. This is the output terminal, okay? This is where we receive information. This is where we send information, okay? This is the, you delivering the mail to the post office. This is the post office sending it to someplace else, okay? When we see a little yellow dot here, that tells us very directly that there is some signal being sent out of this node to some other thing inside of our scene. Simply double-clicking on that little yellow dot on this terminal will expose the relationship. Okay? And it makes sense, right? We're sending the rotation, the world rotation values of this red ring, we're sending it to the constraint. Okay? This constraint's doing some math for us, doing some heavy lifting. And again, we have terminals. Ins, the left side is always in, and the right side is always out. On this particular constraint, we get a little lucky because it literally says output, which is nice. That's not always going to be the case. So if we double-click on this little yellow dot to see what the computer has done for us, the method to the madness can be seen a little bit. Okay, so here's the red ring, its rotation channels, all of its rotation information, the degrees of rotation is being sent to the constraint. The constraint's doing some conversion and some heavy lifting for us. Then it's sending rotation information again out to the blue ring, which is receiving it under its input terminal. Okay, this is kind of like a flow of data between all these different items inside of our scene, okay? The more we think of it like inputs and outputs, the easier it gets, okay? So going back to the goal here, we want to have the blue ring rotate in the opposite direction of our red ring. So we need to make some modifications to this entire graph so we can start manipulating and getting the desired result, okay? I'm going to intercept the signal a little bit, and I'm going to change its values. We're going to modify the data that's being sent between these different elements itself. So I'm going to unwire some of this. So if you click on the little line, okay, we can start to make some connections. These are called noodles. Officially, they're called noodles, which is kind of nice. Some people call them wires, which is just fine too, But we can make, and send the signal wherever we want. Now, this is a cool thing about the way Modo does its rigging system, is that if we try to send a signal to a terminal that doesn't accept that value type, no go. It turns red, stop. I'm not having it, right? When it goes green, that means, yes, I can accept this type of value that's being sent to and from these little packets of code, which is kind of nice, okay? It's a nice little reinforcer of of what's working and what's not working. I'm going to unhook the blue ring from the constraint just by doing that, okay? And now I want to modify it. I still want to send information out, but I want to do some sort of math in here so I can get the ring to rotate in an opposite value. Now, what's specifically going on here is that we're sending degrees, right? The degree of rotation for the red ring is being sent to the constraint. That constraint's doing some math, and it's also sending out degrees of rotation to the blue ring, okay? Well, mathematically, I'm going to force you guys to do math at 10 o'clock on a Wednesday morning, right? What's an easy way to flip an integer, to flip a value? Negative. So what if we simply tell the computer to multiply whatever value it's sending from the constraint to -1? Multiply it by -1. We're always going to get the opposite. Easy math. I'm all about easy math, right? So let's do this. Let's modify our rig ever so slightly by adding in. I love a lot of things Modo. I hate this little quick search thing. It drives me crazy. I like pull-down menus. So if we go into this add thing, and the drop-down menu is going to give us a list, which is kind of nice, okay? And if we go channel modifier math, okay? And you know, this is where the motor rigging system starts to make your brain hurt a little bit, because once you start going in and looking at what you can do, often people get pretty paranoid and pretty freaked out, right? They go, oh, I don't think I'm going to be able to do this, right? Because there's some legit math that's happening. There's even logic that will happen inside of motor rigs. Let's see, I'm not sure if it's in here or in another one. Well, you can, yeah, it's under the conditional categories. You can create if-then scenarios. I saw someone rig a real padlock, okay? And you physically had to go in and spin the dial, and it wouldn't, the top, you know, little U shape on a padlock, it wouldn't allow you to transform and rotate that top U shape until all the numbers on the dial were correct, based off of the conditional statements inside of the motor rig. So you can get crazy detailed in here, okay? We're gonna keep it easy. This math list has ballooned, okay? You can even do trigonometry now, which is just like, wow, what, right? Yeah, I'll save that for the computer scientists. I'm an animator. I'm gonna keep things pretty simple. So I'm gonna do math basic, and then there's multiply, okay? And this is what you're gonna get, okay? So, pop quiz. What are these? Inputs. These are the input terminals. So, the inverse, what's that? Output. Okay? Now, these little math modifiers allow us to do some simple math. Okay? So, I'm going to take the output from my constraint and plug it in here, not there. Okay, it's not allowing me to do it. Why is it not allowing me to do it? That's interesting. It's not allowing me to do any of it. Did I do the wrong one? I might have done the wrong one. Let's right-click, remove the node. Make sure I'm in the right spot. Channel modifiers, math, basic math. Yeah, math, multiple. Let's see. They may have changed. Yeah, nope, that's definitely not it. I hit backspace there. I apologize. Huh? Yeah. See, let's just test it on a basic add. No, it's not allowing me to do anything. Yeah, that's a good suggestion. Let's do this over here. Let's do the math on this side of the constraint versus that side of the constraint. No. Oh, you know what I think the problem is? Yeah, well, I think the problem is, and I didn't notice this until now, it's saying world rotation. So it's taking all three of the rotation values, okay? We want to get it a little bit more granular, okay? We only want it to do one rotation channel at a time. So I apologize, I just didn't know that, I didn't see that when I was doing that. Okay, so let's wire this stuff back together to a certain degree. Although it should still work, but let's just modify this ever so slightly, okay? So I'm going to go back to my red ring, and now I only want to do, let's do rotation X, okay? Now here's the cool thing about working with the properties panel is that I can add just that channel into my schematic if I wanted to. Okay, if you simply right-click on it, it's down here at the bottom. Add channel to schematic. Okay. Oops. I moused off it for a second. Let me get back in there. There we go. Aha! There it is. Okay. Yeah, it's still not. It's rotation. It's still no likey this. It is the wrong data type because now these little things, these little dots here, tell you very directly what type of data it's trying to accept, right? Yeah, see how it's like a 3x3 grid. Really, that is position, rotation, and scale, and then X, Y, Z in each one of those. So right now, it's looking for complete transform channels being sent to and from the rotation constraint. Now let me hold on just 2 seconds. Yeah, no, that's interesting. I don't know if they've changed them because this I've always been able to do this. Just do a simple flip. They in fact making it more difficult than it needs to be. I love that it used to be simple. Yeah, no, okay, let's get rid of that. And that. At the very least, let's wire this back up so that it kind of works. All right. Just trying to make sure they didn't put it in someplace else. This drives me crazy. Yeah. Okay. So let's do this. Let's go back. Let's add in math multiply. Yeah, no, I'm pretty sure. Well, let's do this. Let's do add. Well, add didn't work either, if I remember correctly. Yeah.
I figured it out.
What was your solution, Kevin?
Well, actually, just go to the rotation.
Yep.
Rotation X and then use that one. Connect. No, connect to the add.
Yeah, I did that, and it wasn't allowing me to do it. Yeah, it's doing it. It's allowing me now. Yeah, it was that side. See, because we're sending it in a single rotation over here. And so well, here's what we can do. Say again? Yeah, let's try this. Let's actually override the constraint. This will be fun. Let's just get rid of the constraint for a second. I'm gonna go to the blue ring, add this channel to my schematic. Let's just see what happens. There it goes. Okay. I'm gonna change this to multiply. And what's cool about these modifiers, these math modifiers, is that I've changed the operation to multiply. I want to multiply it by -1. Okay. And now, it even says -1 down there. Now when I rotate this, oh, I was doing X, I'm doing the wrong one. There it goes. Now it's working. Constraint was trying to do all 3 rotation channels at the same time, which wasn't what I was trying to get to. Which is pretty cool, huh? So that's where the schematic kind of comes in and begins to, and shows very directly of what we can do. We can modify the signals being sent from these different items to create the desired result. Okay. Now, if we wanted, what we really could do is do a couple of these at the exact same time. So I can let's do channels Y and Z. Okay. And I'll do the same thing on my blue ring. I'll get channels Y and Z, add those to the schematic. I didn't do it. Sorry. Oh, they're here, sorry. Didn't expand it. Okay. And now, I don't have to have 3 of these things, and just keep that where it is, right? Oops, maybe I do have to have 3 of them. I thought you could do multiples. No, looks like you're going to have to have 3 of them. That's okay. So now I can do that. I'll add 1 more. Math. Multiplier. Yeah, I got to make a -1. -1 on all 3. All right, now wherever or however I rotate this guy, the blue ring is going to be rotating in the opposite direction. Except for along the Z. Did I not do the Z correctly? That works. That works. It's doing it, but it's producing an optical illusion, which is kind of fun. Mm-hmm. And then Z, they're both rotating around their local Z, not the world Z, which is kind of fun. So this guy is spinning, along its rings, the plane of its ring. So it is in fact working. Fun nonetheless, right? All right. There is a way to condense all this into one thing. I've forgotten the name of the modifier off the top of my head, but that's where all of these matrix things come in. And I've forgotten which one allows us to do it, but you can do it, which is pretty cool. All right. Cool, huh? Pretty neat. Pretty neat. Now, what I'm going to do is I'm going to get rid of all of this real fast. Kind of get things back to the way they were. Let's remove the nodes. Oops. It didn't move. It removed the nodes, but it didn't actually delete the nodes. Awesome. Thank you, Moto. There we go. And now we're back. Now they're no longer being influenced by each other. What's cool about the motor rigging system is that everything is undoable, right? At times you have to go in and kind of unhook things from one another, but you can absolutely undo it, which is kind of nice. All right, now I've seriously messed up the transforms of my red ring. It's at a weird angle. Same with the blue. Well, the blue is just fine, but the red one's all kind of walked up, right? So I want to very quickly go in and put this back to its original position. I want all my rotation channels back to 0. What's an easy way for me to do this real fast?
With the link of this, you can link the 3 channels.
Yep.
Set one of them to 0.
I like it. You can link all 3 channels by hitting this little gray 0. Whoop. And what you do to one, we'll do the others. That's cool. What's another way of doing it? Reset. Reset down here is going to restore all of these transformed channels back to their original. So I'm going to restore all of my rotation channels. They go back to 0. Okay. The reset is going to manually put all that stuff back down to 0, and things are starting to go back the way they want to, which is pretty neat. Okay. All right. So the next one that I want to talk about, this one's kind of fun, right? And I think what this is going to require me to do real fast, I want to make another mesh. And on this mesh, I'm going to create, I don't know. I'll create the world's silliest, I'm going to go over the model layout to do this real fast. I'm going to create the world's silliest arrow. Okay. There we go. Oops, clicked off it on accident. Let's go back in, bevel that down. Shift click to refire the bevel. Voila! Arrow. Okay. Now I'm using this arrow very specifically to help me explore the next type of constraint. I'm just going to center this along the x-axis. There we go. All right, let's go back into my setup tab and look at how we can use the directional constraint. Okay, directional constraint is pretty neat. I think you're really going to dig it. Okay, yeah, go ahead.
For some reason, it reminds me of the logo for the moon.
Rock and roll. I like it. Literally rock and roll. All right. Now, what I want now to happen is I'm going to go into item mode. Is that I want to have maybe this arrow, and let's move the arrow ever so slightly. I want to have this arrow always point at the ring, at the center of my target. Okay? So I want this tip to always be pointed wherever that circle is. Okay? This is called the directional constraint. Okay? The basic modifiers over here, all the position, rotation, those are pretty self-explanatory. You can figure out those pretty quickly, right? And oh, FYI, I don't know why they do it, mostly because scale is nested in the position section. And I think I just answered my question. You almost never actually have to do a scale constraint, which is why it's kind of hidden in here. But you can do it. But we're going to do a direction constraint. Now, direction constraints, this is where they become really useful because I want to make sure that that arrow is always pointing at the center of my target. Okay? Center of that big red ring. So let's do it real fast. Let's start our selection. Select the arrow. That is going to get constrained to that. Let's fire off the direction constraint. Aha! Okay, so if you look very carefully here, we can start to see exactly what's happening with the direction constraint. Now, I'm going to undo it. Notice that I have my arrow selected, and I want you to pay very close attention to the orientation of that center point. Okay? Look at the orientation of the XYZ axes. Now, when I fire off the directional constraint and make the connection, what happens? The direction change. Seemingly, the arrow flips 180 degrees. Yeah, well, what is, and we get a nice little line from the arrow to the center of the red ring. Awesome. Okay. Let's prove that there's a relationship working. I'm going to select my red ring real fast. That's cool. Now, the center point of that arrow is always, well, when I move it up, it's just rotating, which is kind of fun. But if I move it over here, you can see that it works. Okay. The center point of that arrow is always pointing towards the direction of the center point of my red ring. Now, that's cool. This isn't necessarily the result that I'm after, though, right? Because I would really like to have the tip of the arrow pointed at the ring. So I need to change some of the settings on my constraints. Now, luckily for us here in Modo, changing properties on a constraint is really easy. Got to go find it first. There's the directional constraint. If we click on it, of course, naturally, our properties tab is going to show us all the specific parameters for anything we click on. I'm in the mesh section. A lot of folks and this is a fault of Modo. I really don't like how they do this. I click on the constraint. I think I should see all the constraint options immediately, right? But sometimes that doesn't necessarily happen. So we have a whole series of constraint options here, and one of which is the axis. Okay, now look at the axis. Right now it's set to Z. This is the default. Okay, this makes a lot of sense if we consider what's going on. Okay, let's get my ring a little bit closer to my arrow so we can see them a little bit more easily on the screen at once. Okay, now if you check out this, okay, look at the orientation here. The entire item has been rotated so the positive section, the positive side of the Z axis for this item is now pointing towards the middle of that item of the red ring, right? Now, in order to get the result that I'm after, the tip of the arrow to be pointed at the center of the circle, which axes should I change this to? X, right? Let's do it real fast. My properties, if I change Z to X. Okay, now the arrow is pointed the right way. The X-axis has been constrained down the directional constraint to the target. Now, it doesn't matter where that target's moved inside the scene. It really doesn't. I can move this anywhere, and that arrow is always going to point at that object, which is pretty rad. Okay? This kind of shows the power of the motor rigging system. You can do some really, really cool things with it. Constraints are incredibly, incredibly powerful. Okay? Let me show you one other constraint. Okay? And this will be the last one. We're going to take a little break, and we'll start working on our catapult a little bit directly. Okay? Because constraints are really kind of the core of the motor rigging system. We're making meaningful relationships now instead of kind of casual, simple relationships. Okay? I'm going to go in and, well, shoot, let's do something a little bit more fun, right? I'm going to create a new Modo project file. And let's do this. Let's load in let's go into the I'm having a brain F6 loads of the preset browser. Gosh, it took me forever to remember that. My coffee hasn't kicked in yet. And if I go into the meshes section, let's see, under vehicles, I think. Yeah, there we go. That'll do. As much as I want to rig this cool little mech, I'm not going to. Yeah, let's do the little airplane. Double click, loads it into the scene. There we go. Good little airplane, right? It's all encapsulated into one item, which is kind of nice. Now, I want to animate this a little bit more directly, okay? You know, for those of you that have taken GCOM 401, you know, animation's hard, and getting curves and paths and smooth kind of movements is incredibly tricky. However, if we begin to pair our Modo rigging system with an animation intent, we can make things a little bit easier for us, which brings us to the path constraint, which is really, really, really cool, okay? Path constraints allow us to connect items along a curve, okay? This is the last constraint that we talk about today. First and foremost, I need to have an item that has the curve. So let's just rename this empty one curve. And on that empty mesh item, let's go into the setup section of our tools and draw a curve. Okay? And the placement of the curve has everything to do with the current orientation of your work plane. So I'm kind of looking at my scene from the top, and I'm just going to draw at a curve now. I don't really care what this looks like too much. Okay, that's going to be the flight path of my little fighter jet. Okay. Yep, that looks good. And now I need to make a connection between these two different items. Okay. Now, like we've been exploring earlier, I need to constrain this item to that item, right? So which of those two items am I going to select first?
Jet.
The jet. You got it. That, hold down shift, gets constrained to that. Okay. And of our tools over here on the left, where am I going to go to find all of my constraints? Which tab? Modifiers. You got it. So if we go into modifiers, now we're going to do the path constraint. Boom. And now our airplane's on that path. Okay? Now you're probably saying, cool, that's fun, but you said he was going to fly down that path. Well, like we had on our directional constraint, we need to go in and start exploring some of the path constraint options. Okay? And what we're looking for is path percentage. Okay? Path percentage, I'm simply just going to scrub through the value here. Of course, that's an animatable channel too, right? Let's just do it real fast. Let's put it at 0. Set a keyframe there. I'll go to frame 120. I'll put it at 100%. So 0% is the beginning, 100% is at the end. If I play my animation now, maybe our animation supervisor or a director comes in and says, awesome job, we need to change the path. Is this a problem? No, not a problem at all, right? We can even do it while the animation's playing. Okay, I need to go get some control points from my path. Okay, I want to stop it. All right, so Just move the control points of my path. Oops, excuse me. Okay. Just play it again. Cool, huh? Pretty neat. Path constraints are amazing. Yeah.
Can you hide the path just have the plane, still go in the same path?
Absolutely. Yeah, for sure. The path, you can turn off its visibility if you like. Well, I'm clicked on it. There it is. Curves are never going to be rendered. You'll never see a curve in 1,000 years. Okay? So you don't have to worry about them ever showing up in your final animation. But they're infinitely useful. Let's continue this thought, because path constraints are something that we use a lot. Okay? Where could it be another place that we would use a path constraint?
Catapult moving forward.
Okay? Yeah, absolutely. It's a good idea. Seriously.
An object flying through the air other than a jet.
You got it, right?
Boulder.
I like it.
Roller coaster.
A roller coaster, for sure. That's a great idea.
A walking.
Yeah. Yep. For sure. Complex, but we can do it.
You recommend using this for like animatics?
Or even production. Yeah, we don't have to limit it to just, kind of, simple things. Here's another great one. Cameras. Yeah, because cameras are an item just like any other item. We can constrain a camera to a path, and now we don't have to set keyframes for that camera, and we'll always get nice, smooth camera movements, right?
Now, after you constrain that camera to the path, constrain the camera to like the airplane flying on this path, that constantly.
Absolutely, yeah. So if you wanted the plane, or excuse me, the camera to be a certain distance from the plane, the rigging solution to that is not to make an additional path for the camera, although you could do that. Okay. Yeah, you got it. Okay. So let's just do it real fast, since I just happen to have a camera right here. Okay. And let me look through my camera and just kind of compose the shot a little bit. So maybe that's the perspective of my airplane that I want to have throughout the duration of my shot, right? I don't want that composition to change, but I do want it to follow the plane, right? So what am I to do? Just parent it. Okay? Now it becomes a child of the plane. Wherever the plane goes, so goes the camera. Okay? Let's kick this up a notch. Okay? So we're all about, I'm like an Emerald Lagasse. Kick it up a notch. Whoa, put paprika in there or something. Anyways, he's a famous chef. Most of you guys don't know who I'm talking about. Yeah. All right. I saw a question. I want to make sure I answer the question. Yeah, Sue, go ahead, and then we'll get Kevin.
Can you create like a path for the camera and a different path for the plane?
Yep.
And then have, how you did the arrow with the circle?
Yep.
The ring, have the cameras, follow the plane, even though it's not necessarily following the same, or not parented to the plane.
Absolutely.
Focus on the plane, even though it has its own path.
How can we create that? What type of constraint are we going to need to make for the camera itself? Directional constraint, right? Because we can put multiple constraints on one item. Let's actually prototype what Sue just kind of fleshed out. Because if this begins to show the power of this constraint system, and it's great. It's almost as if you read my notes, Sue, and I like that. Because I was going to go into that here in a second. Because we can have multiple constraints active on one item, okay? We can have a lot of different constraints, okay? I'm going to unparent my camera from the airplane. So now that they're unhooked from each other, okay? And now let's just pretend that, just for clarity, let's call this plane path. And I'm going to create a new one. And on this other one, I'll call this cam path. Just so we're really, really clear. All right. This is just for me and my own visual hierarchy. I like to kind of group things in the item list, kind of visually to just makes it easier for my brain to understand the relationships. These two are working together. These two are working together. Just me though, because I'm crazy and weird. All right. So on my cam path, let's just make a very simple path, and I think for me, honestly, what I'm going to do is just do a straight line. Okay. Okay, we won't do a straight line. That's boring. There we go. A simple little curve. Okay? That's all we need. Let's constrain camera to that. Go back into modifiers. Path constraint. Okay? There we go. So now this thing is always following the path, right? Now how can I get, if it's always following the path, how in the world, well, if I rotate it,
Well, now rotate, we got restraint.
okay? So this is part of the challenge of rigging. This is a good challenge. Now, maybe maybe we'll do axis. We'll do X. Okay? That's interesting. How about Y? Now the Y-axis, we're pointing down. That's not exactly what I want. So this kind of adds to the challenge a little bit. How do we get to the result that we're after? I want the camera to follow its own path, but I always want to have the camera looking at the airplane.
Directional constraint to the airplane.
Yep, we're going to need to get there eventually, right? But now we need to add in some new things into the mix, okay? What the path constraint won't allow us to do is to rotate this thing individually. Okay, I'm trying to rotate my camera. It's always going to be locked to the path. I can't move it. I can't rotate it. I don't believe I can scale it. Okay, so how am I going to get that camera on the path and still be able to preserve the rotation of it? This is where the out-of-the-box thinking comes in, and we're going to add in a new element into our rigging system, one that we're going to see very actively on every rig going forward, and it's just simply called a locator. Okay? A locator is an item. Since we work in an item rigging system, it becomes something that we can constrain and parent and work with. Okay? And this locator is a non-renderable item. There it is. I just added one into the scene. That's it. Most importantly, it has transform channels, so the computer's always following where it is inside of its three-dimensional space. It's always going to know its position, rotation, and scale channels, okay? Let's do this. What if we had a two-tiered system for this rig? What if we constrain the locator to the path, right? And then parent the camera to the locator. The child, which would be the camera in this particular situation, can still be manipulated, right? We learned that last week. Let's do it. Let's just prototype it. Let's see if it works, okay? I'm going to go in and get rid of this camera's, whoops, path constraint. Don't need that anymore. All right. So now what I'm going to do, same thing, and grab the locator. That gets constrained to that, path constraint, okay? Let's animate its path percentage. There it goes. Slowly moving. It's always just going to, it's like a railroad track, these paths constraints. Okay? Now, what if I take my camera and I'm going to move it kind of close. It doesn't have to be exactly on the locator. Actually, I think for visual purposes, maybe it's best that it's not at the exact same location, just so we can see what's going on, okay? So now I can take my camera and simply parent it to my locator, okay? Now, wherever the locator goes, it's going to drag the camera along with it. Hit the play button, we're off to the races, okay? Cool thing about these parent-child relationships that we explored last week is that the child can still be manipulated, okay? Now, earlier, Sue said, I want my camera always looking at my airplane. I'm in item mode, so I have my camera selected. This gets constrained to that. We'll do a directional constraint. Now, the camera's always going to look at the airplane, but it's going to move along its own independent path. In addition, if my director walks in and says, Pat, I love what you've done, but, editorial has come back and said we need to move the camera location a little bit. I move the path, which changes the location, the locator, which then changes the movement of the camera. And things are all update live in front of us. Okay? Cool, huh?
Shut the camera view?
Yeah, the camera view is going to be kind of wonky because there's nothing in the background. It's really not going to. It's going to be kind of meaningless. But proof of concept, it is actually working. Yeah, it doesn't really. It kind of breaks the laws of physics a little bit. Our airplane, not exactly. Although if you're in like Star Wars, this is like an X-wing. You're like cool, right? It drives me crazy. Yeah, they break all rules. They're like, we can have our spaceships fly however we want, right? We can have our spaceships in space go from like full thrust to like all stop in like 1 second, then go a different direction.
Just crash.
Well, I mean, they haven't been following laws of physics since the first movie. So
That's true.
At this point, it's kind of
It didn't crash, and actually Tyler pointed something out. It is the autosave getting in the way. I don't know if you guys saw it, but that autosave button said it came up, and there's a countdown clock, right? 10 seconds to autosave, and then it auto-saved. While it was auto-saving, my animation was playing back, and Tyler and I both thought Moto was going to crash, right? I find the autosave worthless, okay? It gets in the way, and it actually causes a lot of crashes, because if you're not paying attention to that little countdown timer, you could be right smack in the middle. You could have just like fired off a modeling operation, and if you do that operation and the autosave at the exact same time, Moto goes, I don't know what to do, and it crashes, right? It's like, I'm trying to do two things at once. Crash, right? You can turn it off. I clicked on the wrong button. Autosave. Bye-bye. Okay, now it's not going to be on. Yeah, I turn autosave off immediately because I've learned from my experience that 9 times out of 10 that's the cause of most crashes. Okay, so did this make your brain hurt? A little bit. If it made your brain hurt, that's okay. This is as I mentioned last week, this is going to challenge you a little bit. Okay, rigging's not easy, but the more experience we have creating these rigs, the easier it's going to become.
It's a lot of steps, but all the steps are like they all logically connect.
Yeah.
It just makes sense.
And that's both the good part and the bad part about rigging, right? Is that we have to figure out what those steps are. But once we figure out the sequence and what we're trying to build, the steps are actually pretty easy. It's like understanding the machine before you make it, right? And sometimes you have to experiment. And sometimes you have to fail. Sometimes you run into not sometimes. Every step of the way, you're gonna run into a problem that's gonna make you go, that's not doing what I wanted it to do. Okay, now I need to invent a solution. Rigging is very humbling. At all moments in rigging, you're going to go, I don't know what I'm doing here, right? And that's okay. It's part of the process. It really is. All right. I tell you what, I've been going for almost 2 hours now. Why don't we take a very short little break? We'll come back in and we'll start looking at our catapult rig. Sound good? Okay, back by 11 o'clock, please. All right. So while you guys were on break, one of the things that I did, I just kind of cleaned out Modo and started anew. So all new project files, just closed everything out because I wanted to take a look at the Catapult rig that I provided you. Okay. This speaks very directly to our homework. Okay. Let's take a look at it and just download it. All right. Open it up. So here is the model file as soon as it chooses to load. Maybe. Okay, here's the model file. Okay, pretty cool. I made this a long time ago in a galaxy far, far away, so this is yours to keep. You can do whatever you want with it. In previous iterations of this class, 10 years ago or so, we all did a castle siege animation. That was fun. And so this is one of the props that I made for that project. So do with what you like. I don't care. It's your model now. But it gives us a great opportunity to start exploring what we need to produce for the rig, the control rig, for this very file itself. So the first thing that I do as an animator, whenever I come in and someone supplied me with something, is that I do a fundamental deconstruction of the model itself. I need to figure out its working pieces. I need to be very, very comfortable with the mesh before I can rig it. In some studios, often the person that makes the model will do all the UVs and then also do the rig. They won't necessarily texture it because some studios have texture artists and shading artists, and it kind of more integrated into the lighting division than the asset creation division. But in some places, actually I know more than a few, if you model it, you UV it, and often you rig it as well. Okay. So let's take peel back the veil to a certain degree and look underneath the hood at this specific mesh item and get up close and personal with it. Okay. From what's been supplied, the mesh has been broken out into two separate items, and this is a good place to start. We have the actual base of the catapult here, and then another mesh item for the arm itself. Let's do some investigation of some center points. Where did I place the center points and the pivot points for all of this stuff? It's down there at the bottom for the catapult base. I can see that. I've turned off the visibility of my grid, but if I turn it back on, it looks like the center point for this particular mesh item is at the origin of the scene. Great job, Pat. I know what I'm doing from time to time. Okay. However, let's look at the center point for the arm. Cool. It's generally speaking where I would like it to be, right there in the center of kind of the axle, if you will, for our arm, which makes it a little bit easier for us to rig and to manipulate. Okay, I like it. I always do a simple test. It's like if I just fire off item transform and kind of play around with it, monkey around with the items, is it generally sitting where I want it to sit? I want the center point for this, for the parts that are moving, to be in the correct location. That's really, really important for us because as we explored last week with our chain, all of our rotation, all of our transforms, okay, happen at the location of the center point and the pivot point. Okay, so a good, healthy investigation of where they're currently at is a good idea. Okay, let's put this back to 0, the rotation, so it's at its resting pose. Okay, so that's the mesh items. Are there any UV maps? Let's find out. There is no UV maps on that mesh item, but on the base mesh item, there's a UV map. They're all over the place. They're there. This mesh was originally designed for a tiling texture workflow, so you're more than welcome and encouraged to do whatever you want with the UVs, but they're all there. So if you've taken one of our game art class or you're comfortable working with UVs, go crazy, man. Roll this through Substance Painter. There's a lot of data here that's already been constructed. There's no reason not to make it really kind of cool and personable. Okay, so the catapult has some. The arm, doesn't look like the arm has any UVs at the moment. So keep that in mind. Yeah. All right. So this assignment's not about UV maps. It's all about rigging and animation. So let's go back over into our setup tab and look at what we need to do to get the desired result. As we explored earlier, the first thing that we need to do as character riggers is to fundamentally ask the question, what does this machine need to do? Because there are no super rigs. There's not one rig that's going to do everything. So what do we need to have this rig do? here's the literal moving parts. Okay. Yeah. All right, I love it. So we need to have some sort of control mechanism for the entire catapult. Ideally, it'd be great to make it easy for our animators, right? We don't want our animators going in and monkeying with stuff that they don't need to be monkeying with, all right? Because the animators, they're not modelers. They're not riggers. They can break things pretty easily. So it's kind of like, I was talking with someone a couple months ago about we're making a CNC machinist program here on our campus, and I was included in that conversation since I do a lot of the 3D modeling stuff, right? And this particular individual had a tremendous amount of practical real-life experience working on Jaguars, cars, right? And he's like, yeah, it's pretty frustrating from a support side because Jaguars, they're designed to be brought into like an official service center with authorized, certified Jaguar technicians. They're incredibly difficult for a driver or for an owner to kind of mess with, right? They do that intentionally. It's like the engine compartment's small and everything is compact because they want you to bring it into a service center and have someone who knows what they're doing kind of fix your car, right? And given the price point at which Jaguars are, you're not going to have most owners popping up the hood and changing their own oil and things like that. We kind of have to have a similar perspective on our stuff, right? I don't want my animators messing with my polygons. I don't want my animators messing with my rig, okay? I want to try to hide some of that, so I'm only exposing maybe the control surfaces that really drive the rig, but they don't influence the rig, okay? That's going to be another layer that we're going to put on top of this. How can we create little bells and whistles, little toggles and switches that will give our animators the functionality without having to worry about if they've broken something, right? Because it's very, very easy to break something in a rig. It really is. So we want to kind of limit the experience to ensure that it works. All right. So it'd be great if we had some sort of like master controller, right? Like click on like one big ring and I can like drag the catapult and move it around the entire scene. That'd be awesome, right? That'd be really, really cool, okay? And then in addition, as Al pointed out, we need to have all the wheels turn, okay? So if I move the catapult forward a little bit, the wheels turn a little bit, right? Second thing. The third thing that we need to create is that arm movement, right? That's actually the easiest part of the entire animation itself, things that we can very, very, very quickly do, okay? So let's first start to deconstruct and break apart this model so that we're able to get the rig going the way we want it to. Now, I'm not going to do all of this for you, but I am going to start doing maybe just a little bit of it so you guys can start to get a good understanding of how these pieces flow together. All right. So if you look at the model that's been provided, what's the next step? Yeah, separate the wheels out from each other, right? That's an important part. The wheels need to move, so they need to be separate in their own items so we can allow them to move. All right, so let's get that going. So I'm going to go into my polygonal selection set, and I'm going to just turn off my arm. And this is where you have to be a little bit careful with your selection engine. I'm kind of lazy. Yep, I'm just going to, for me personally, in all honesty, I'm just going to hide those two pieces, which gives me a nice place to make a selection, okay? And then if you get the U key to unhide it, everything pops back in, okay? And now I'm going to start cutting and pasting from one item into another item, okay? So Command X to cut, we'll make a new item, Command V to paste it in. Let's give this mesh a good name. This is a wheel. Which wheel is it? Well, it's the front, and I believe this is the left wheel. Yeah, left. Well, is it my left, or is it the object's left? If it's the object's, then this is actually the right wheel. No sneezing. Lock it down. Take that outside. I'm joking. I'm being silly. Okay. So there's one. Now, every time we make a new item, we have to analyze that item's pivot point and center point, okay? Last week we spent a lot of time talking about the pivot point, okay? There's actually another component in here that we need to be aware of. It's actually called the center point. The center point is a little bit different. On the surface, it feels like it's doing something similar, even maybe the same as the pivot point, but there's a big difference between them. The pivot point is actually responsible for the transformations. And it's animatable, which we saw last week. The center point, not animatable, but it has a similar influence on our object. What we actually see here on the defaults, notice the disk down here at the center? That's the center point. It's hard to see because the pivot point and the center point are sharing the exact same spot inside of our scene. The pivot point has that little checker grid on the disk. The center point is just a white disk. So I'm going to go in. I hit the 6 key on my number pad, or on my top row, excuse me, and I'm going to go in, see if I can select it. It's kind of in the way at the moment. I'll move it away from the center point. Yeah, see how now we can very easily see the difference. Which one's that one? That's the pivot points because that little checker pattern on it, and that's the center point. Okay, we can move both the pivot and the center point independently. Okay, the big difference between them is the center point cannot be animated, right? Or its location cannot be animated, unlike the pivot point, which can be animated. Okay. The center point's role, this is kind of going all the way back to when Modo didn't do animation, okay? In all honesty, it's weird. I was looking through my personal user account the other day with the Foundry, and I have every single version of Modo that I downloaded, right? And the first version of Modo that I downloaded was 0.08. That's how long me and Modo go back. And in the early days of Modo, we didn't have any sort of animation capabilities. It was just modeling, believe it or not, right? I think animation came on version 4. I think that's when animation really started to roll out. So in the early days, they had just the center point, which is kind of a representation of the center of the geometry, okay? So that's why it's still kind of hanging around, right? The pivot point was created to facilitate the rigging in the animation engine. So I'm going to go back. Hit undo, put my pivot point on top of my center point. Now, a second ago, when I had the pivot point, okay, see how when I change the pivot point, the center point stays where it is, okay? However, hit 7, and I grab the center point, it's going to wig out, okay? When I move the center point, it automatically moves the pivot point along with it too. Okay? Kind of a distinction. We can move the pivot point independently from the center, but the center point is always going to move the pivot. All right. So point being, what we need to do on every piece of geometry here, on every item, excuse me, is that we need to ensure that its center point or its pivot point, okay, need to be right where I want that object to rotate around. Now, in the context of a wheel, where do I want that center point to be? Center of the wheel, right? Because our geometry is always going to rotate around the location of the center point or the pivot point, okay? At the moment, if I was to rotate my wheel, yeah, it would be rotate, not in item mode, excuse me. If I rotate my wheel, yeah, that's not the illusion that we're after, right? So we need to fundamentally move the location of my center point to the center of the wheel. Okay? Now, let me grab my item, and I'm going to go up. I'm a big fan of the keyboard shortcuts when it comes to moving center points and pivot points. 7 is the keyboard shortcut that will activate the selection of your center point. Okay? Now, you're more than welcome to select your center point and do it by eye. You could do it. It's a pain in the rear, but you can do it, right? But if you're off, what's going to happen if you're off? Yeah, if you're like, oh, I'm kind of close, that's good enough for me. And then if we select the item, there's going to be a wobble in there. And maybe in the context of an old-timey catapult, that's okay, right? Maybe they didn't have, the ability to make, right, yeah. But I want it to be dead on center, not just kind of close. I want it to be exactly centered down, okay? So check this out. This is actually kind of today's moto trick of the day, and this is a good trick. This trick is really geared towards the rigging workflow, and it's something that you're going to do about 8 times in the context of this rig. Okay, it makes positioning center points very, very easy. Admittedly, it's a 3-step process, so just hang with me for a second. Okay, the first thing that we need to do is do some analysis on our geometry. I'm going to turn off my light. See how the back side of my mesh isn't showing me the wireframes as I would like? If you turn off your lights, it's a little bit easier to see some stuff. Okay. So if we look at this piece of geometry, I can see that there is an edge on the geometry itself, right there, that represents that's in the dead center. Okay. Really what I want to have is the center point for that wheel to be in the center of that circle, which I'm assuming is going to be the middle of the axle for the wheel itself. Okay? That's an assumption that I'm making, but I think it's a pretty good assumption. Okay? So here's the trick. I'm going to use my work plane to help me out here a little bit. I'm going to align my work plane to that selected edge loop, and then the work plane has a center point, right, that you don't actually ever see, but then I want to move the center point for my wheel to the center of my work plane, and things are going to magically pop in. To make it a little bit more obvious, what I'm going to do for this item is just move the center point way over here, just so it's really clearly easy to see what's going on. So the first thing we've got to do first is make a selection, and that selection is going to determine where the center point for that object is going to go. Okay? Next thing, we're going to align the work plane to that selection. This is also a new difference in Modo. Okay? In previous iterations of Modo, this was a pull-down menu. You click and hold, and the options that would pop up would be align work plane to selection. Well, they've simplified it. Yay. I like this. Is a good area of simplification. And what they're basically doing now is that if you just click on it, it will align the work plane to whatever you have selected. Now, if you want all those options, just got to click on the option key and click on the button, and you get everything you had. And this is the one that will align work plane to the selection. Okay? That's the command that we're firing off. And that's the command that's fired off every time you click on the work plane button. All right, so I'm going to align the work plane to selection. Next step, hit the 7 key and grab the center point for that item. Now, we don't see the work plane, but it's actually in the center of this wheel right now. If I go back over to the Setup tab, down here we have to work plane position. That's going to take whatever is selected and automatically move it to the center of the work plane. Let me zoom out so you guys can see it. Yoink. There it goes. Okay? Then we'll turn off the work plane when we're done. Let's do that one more time because it's an important sequence. It's a critical sequence to this entire rigging thing, okay? Because we want to use the work plane's center point, okay? The work plane is a grid, and all grids have an origin, right? So we're taking the origin of the work plane, and we're putting it in the center of the thing that we have selected, right? And then we're using the computer's understanding of the origin of the work plane to move another element to it, okay? Does that make sense? Okay. Once you do it a couple times, admittedly, some muscle memory will kind of click in, and you'll start figuring out. So since this is the idea is to take a selection and move the work plane to the center of that selection, I'm going to select that ring. And you don't have to do this in edges, by the way. You can also do it in polygons, just to prove the point. If I grab that polygon right there, I'm going to center the work plane along that object. Bloop. Okay? If I go grab my center point, there it is, and then under the setup tools, choose to work plane position, there it goes. Okay, it got centered to that piece of geometry. FYI, this is also a super, super handy tool or super handy workflow when modeling. When you want to have two things that are absolutely aligned to each other, this is great. Okay? All right. I'm going to go back to edges, align my work plane to that selection, and do the exact same thing again to work plane position. Now, you got to make sure that you deactivate the work plane when you're done, okay? Because all of our tools reference the current orientation of the work plane, okay? So things are going to behave very, very oddly if you don't turn this off when you're done. There we go. So if we return to item mode by hitting the number 5 key, select the wheel and activate item transform, oops, now I'm going to be able to get the rotation that I'm after. It's spinning around its own central axis, which is what I'm after, okay? All right. Things are looking up. I like it. We're moving right along here. So that's part of what we're going to try to do. The other part that we want to have here is, or once we separate out all of the movable elements into their own items, now we have to start checking off the to-do list for our rig, right? I mentioned for my rig, what I thought would be really handy is to have some sort of master locator, master controller that will allow me to drag my Catapult rig around where I want it to go. That would be pretty sweet, okay? Instead of having my animators physically select the mesh, ooh, okay? I don't want my animators touching my things. I'm kind of OCD about that, right? I want them to mess around with the locator, okay? These locators we saw previously, but they can be changed a little bit to make it, you know, a really cool little piece of interface, if you will. Okay, check it out. I'm going to add a locator. I'm going to add locators right here instead of our setup tools. What's the default location for every single locator? The origin. So look at the origin for its location. Okay, so this is going to be my master controller. I'm happy with it at the origin, but man, those little crosses, they are wicked hard to select. They are quite difficult. The guys and gals down at the Foundry have done us a solid, and I am a huge, huge fan of this. Check this out. If you have your locator selected, we have some display properties. Okay? And we're going to do add draw options here. And now we can change its color if we wanted to. Okay? But we can go a little bit further than that. Okay? You can change. So these are the color properties. Maybe I want it to be like a really bright red. Okay? That's pretty cool. Now if we look over here in the scene, when it's unselected, parts of it is red. Awesome. Like it. Love it. However, so that was in the display channels. The display property is going to allow us to do color. You can actually put a label on it. So you can do like master controller. Check it out. Even shows up. We can offset it. Maybe we don't want to like right on top of it. Oops, I'm all zoomed in. I just moved it a kilometer on accident. There we go. So there's some cool things in there that allow us to customize the visibility in our understanding of the role of this locator in our rig. One other thing, and this, so display is all about like colors and labels and things, okay? If we go back to the root locator section of our properties, we can also change its shape, and this is pretty neat, okay? This is the default shape for our locators. However, we're not limited to that. Let's do custom, and now check it out. Got a whole series of shapes that we can use, okay? You can use cubes or boxes. I'm going to do, let's see, a pyramid, it's fun. I'm going to do a circle, and I want it to be aligned pointing straight up and down. I don't want it to be filled in like that, so I'm going to have it like that. And let's see. Yeah, and I want it to be a little bit bigger. It's pretty small. I want a gigantic ring going around the outside of my rig, so I'll make my radius quite big. There it is, okay? Boom. That's a really easy thing for folks to select now. I have a big red ring, okay? Can click on it, bloop, I'm ready to go. So when I click on it, I want to be able to, move it around and have the rest of my scene also move around, or the rest of my rig also move around. So what do I need to do next? Parents, yeah. So let's get things working here. So I'm going to call this locator master control. It's like from Tron, the MCU from Tron. Any Tron nerds out there? I love the original Tron. It's so great. Greetings program. Anyways, I love it. Anyways, okay. So now I'm going to start parenting the components of my rig to that master controller. Okay. Now I have my visibility of my arm turned off. There it goes. Ha ha. Woohoo! Yay! It works. Okay. At the very least, it works. I can still animate my arm independently from that. That's cool, right? If I was to change the rotation of my master controller, everything works the way it's supposed to work, which is pretty cool. All right. So now we're getting there. 2 out of the 3 things done. I'm going to reset the rotation of my arm, get that back. Now the last thing that we need to do is get these wheels to work. Okay. Now I'm going to do one, and you guys are going to do the rest. Okay. The wheels are the fun part. The wheels require us to go into the schematic a little bit. Okay. Let's do some deconstruction. What rotation channel on my wheel do I need to manipulate? X. You got it. So if I fire off my rotation, it's the red handle. Okay. And sometimes I do that. I just move it and I look at what numbers are changing over in my properties panel. It's all of that. So I need to influence rotation X on this wheel. Okay. This is a lot of fun, by the way. Let's do this. So open up my schematic by minimizing my 3D viewport. Okay. And start rocking and rolling here. I'm going to grab rotation X on my wheel. I'm going to add it to my schematic. Okay. There it is. So now I've exposed the rotation channel that I'm after. It's that guy right there. That's what I want to influence. But what's going to be influencing it a little bit? Okay. Here's what we need to do. I'm going to grab the locator. Okay. And what I need to have is its world position. So the position of the locator is going to influence the rotation of the wheel. Which is pretty neat. Okay. Let's check it out. Channels. Okay. And this is what we're after. Position X, Y, and Z. These are the raw channels, by the way. These are all the raw animation channels for this item. Okay, and there are a lot of them. So here's the locator. You could do these 3. I'm going to just use world position. All 3 is basically taking all 3 of these channels and putting it into one. Okay, you can even drag and drop it into your schematic, and it's on the way. Another thing that I like about the Modo schematic is that it gives you the label, or the display properties. We change this locator color to red, so that red is showing up there. Thumbs up, Foundry. That's pretty neat. Makes it easy to color code things. All right. So we have a little bit of a problem, though, because we need some sort of translator, some sort of modifier of the data, right? Because we can't take position data, which is just coordinates, and plug it into rotation data. Because what value are we capturing with rotation? Degrees of rotation, right? Coordinate data, position, does not equal degrees, right? We're sending values from one thing into another. Those value types need to be the same, okay? They can't be different. So we need to have some sort of translator, some sort of modifier in between here that will allow us to very quickly go in and get the result that we're after. For us, this is called the revolve modifier, and I find this thing pretty fantastic, okay? It's a little bit hidden. It's under the add menu, and it's down in the channel modifiers, and then other. It's way down here. I apologize. We'll zoom out a little bit so you guys can see the folder hierarchy. So it's channel modifiers, other, revolve. If we add this modifier into the mix, aha, look at it, check it out. If we look at the ports that are open to us, we have position information, rotation that I accept as an input, and then angle output. That's interesting. Percentage output and distance output. Okay? Well, we have world position information that we can plug in, and then I want this little chunk of code to pop out angle information. Okay? Now, if I grab that locator, the wheel's going to move. Cool, huh? Pretty nerdy. I like it. And one of the things that's cool about this is that if we were to move it a little bit, the wheel moves a little bit. It's not like we're moving the catapult a little bit and the wheel spins like 3 revolutions, right? There's some nice kind of attenuation between these two ideas, which is pretty neat. I like it very much. All right. So that's your mission this week, is to rig this little catapult, to go through this sequence, to flush it all out. I'm not going to do any more. That's up to you guys to figure out and get real good at this. But our job is to rig it and then animate it, right? I want you at the conclusion to make a very simple animation, not too dissimilar. Be creative. Don't copy mine, because mine's not great, okay? Make something that looks very similar to that. Your catapult comes in, fires off something, and you're done. Relatively short. We're not looking for anything long here. But it's important that we're always, always, always practicing our rigging, our animating, and our rendering, okay? There are a couple of details that I want to make sure everyone hits for this project, and I'll give you the rest of class to work on this animation, okay? When it comes to the specifications of our rig, I'm usually 9.9 times out of 10 going to tell you exactly what I'm expecting you to build, okay? So there are some specification. Catapult must roll. At some point, showcase the control rig for the wheels. So I want to be able to see those wheels turning, okay? Arm must swing, but you don't have to make it launch a rock or, a flying chicken or whatever. I don't care. It doesn't have to have anything in the, yeah. It absolutely can be a flying chicken. No bonus points will be, did you really? Flying chicken? Yeah. I'm launching me a chicken, right? Yeah. You can go all Monty Python, launch like a cow, right? You guys ever see that from Search for the Holy Grail, launching a cow? Anyways, no bonus points will be awarded for launching something awesome, but you will get pat points, which are not really worth anything, but I think you're cool. No more than 200 frames, okay? So it's going to be longer than what we previously did, but this is not going to be Herculean. This is not like 30 seconds worth of content, okay? Just under 30 seconds, what is that? Just under 8, yeah.
How many frames would you say? I don't know.
No more than 200 frames.
200?
Maximum, no more than. I don't want this to turn into a humongous animation, okay? So I want it to, have it roll in, fire something, done, okay? 3 or 4 seconds max. That's it's less than 3 seconds, okay? And you're going to be rendering, and this is really, really important, okay? Because I want to make sure that you guys are triple checking your render settings. 1280 by 720, okay? If you look at the project file that I supplied you, is the frame resolution for the project file 1280 by 720? I really don't know, so let's triple check it. Where do we go to find out the frame resolution, the render settings for this scene file? Camera, you got it. So we'll go into camera, we'll look at its properties, and it's actually not in camera. I apologize. It's in the render item. So if we go into the shading tree, specifically this little purple sphere, this is called the render item inside of Modo. If you click on the render item, downstairs, then frame width and height, 1280 by 720. So this one's ready to go, but not all are going to be 1280 by 720. It's your job to triple check this, okay? I will start removing points from your project if you're not submitting at the proper frame size, okay? It's an expectation that you do it correctly. All right, back to Canvas. Okay. One thing, please do not copy what I have done. Be creative. Have fun with it. It's only a couple second animation. One personal suggestion that I would make, and this is not an expectation, but I think it's a professional kind of expectation. Take every opportunity to make pretty pictures, okay? Look at your lighting, look at your materials and your textures, okay? Make a little scene file, okay? Notice that there is no expectation that you make like a castle or a field with grass, and I didn't put any of that in there, okay? Use every opportunity that's provided to you to make a portfolio piece. Many of you, this is your last class with me, okay? So you're going to be entering on to, onto the real world or into the workforce or maybe even a four-year institution very, very soon, okay? you're going to need a portfolio to show your awesomeness and how talented you are. This is a great example. This could be, if you put some energy into it, a really cool animation. Okay? You've already created a cool rig. You're 25% there. Okay? Make a cool animation. Now you're 50% there. Put a little bit of investment in time and materials, textures, kind of flush out a simple little scene. Now you're 75% there. You give me good lighting and good renders. Now you're there. Now you actually have a good little solid portfolio piece. Okay? It doesn't take too much more energy to make something that's truly worth something worthy of your portfolio. Okay? Take every opportunity. This is a good start. Many of you guys are in the portfolio class this semester. I think that's awesome, and I've been seeing you flow through my class, asking questions about what pieces should go in your portfolio and what should not go in your portfolio. Great conversations coming out of GCOM 349, right? One of the problems that some folks are experiencing is that they don't have enough. They don't have enough content for their portfolio, right? Content, okay? Opportunity. Take every chance that you get to make something that's really impactful, okay? And this stuff is fun too, which is pretty neat. So, yeah.
You guys said something always practice what? Rigging, animating, and what?
Rendering. Yeah, you got it. Yeah, those are going to be like the three tent poles, like the three stool legs of this class, right? Rigging, animating, rendering.
Where was the frame rate?
So the frame rate. So we can adjust our frame rates.
Yeah, I wanted to adjust.
Yeah, down here in our sequence settings.
Oh, not that. It's just that I meant setting how wide or.
So not the frame rate, but the frame size. Yeah, the frame size can be found when selecting your render item. So I'm in the shader tree at the moment, so I'm in the shading tab. I'm looking at the shader tree. I've selected the render item, and it's one of our render properties, the frame width and frame height. Just make sure it's 1280 by 720. You're ready to rock and roll. You got it. We're not going to be rendering at this resolution on every single project, okay? Towards the end of the semester, you're going to hate this, but we're going to actually graduate into full HD 1080p, okay? Yeah, it's good. It's good. I may even, depending how angry you guys make me, 4K. I may actually force you guys to render at least a still picture at UHD, okay? Because it's going to take forever. Yeah, it's going to take forever, yeah. Rendering at 4K is intense, yeah.
It takes a while, but it's also passive time.
It is. Think of it like this, though, because this is going to be something that's new for you, Dominic. You've just been used to rendering still images, right? If it takes a half an hour to render one picture, if you're just rendering one picture, no problemo. I'm going to go have lunch, check my email, hang out, back in 30, I can get my render. But what if you're rendering 300 frames? 30 minutes each. At 30 minutes each?
Yeah, when I rendered the chain, I accidentally didn't change the resolution.
Uh-huh.
And I rendered the entire thing, and I went, oh, crap.
I'll be back tomorrow. Yeah.
It took another 20 minutes to render.
Yeah. Yeah, the 4K resolution it gets intense pretty quickly. It looks so good, right? It's feature film quality, renders, but on our little iMacs, they certainly take a long, long time.
I wonder what NVIDIA's new graphics card, RTX ray tracing things, or if that's going to make a difference on this.
Not on the iMacs, yeah.
I'm saying new computers, will it make a difference rendering a Moto?
No.
It won't?
It won't, because Moto does not have a GPU renderer. Okay. Moto's render is all CPU. Okay. So these new graphics cards are only going to really have a big impact on the OpenGL viewport. Okay. If you've poked around in Moto a little bit, and I'll just go to the modeling layout just to kind of illustrate this, okay? Of course, we have the default viewport properties, okay? This is using the advanced OpenGL shading system, shading architecture, to draw all of our polygons, okay? Of which is going to be deprecated by Apple, which I'm really kind of unhappy that they've chosen to walk away from OpenGL, right? In favor of their own technology, which it admittedly is superior, right? their metal architecture, and that's literally what it's called, is awesome. It's fantastic. Okay, it gives developers access to the actual GPU, the raw silicon. There's not some sort of software interpreter that that you have to go through, right? But for us in the for the iOS app development side, rock and roll, thumbs up, it's perfect, right? For us on the 3D side, this is a major, major problem because almost every single major 3D app uses OpenGL as its core architecture, right? So that means like every app has to be completely rewritten to work with metal, okay? Because Apple is just not going to support OpenGL. What they get there's a timeline, and I think it's by next year. So
that's going to affect Mac users.
Yeah, Mac users. Yeah, yeah. PC users, we'll see what Microsoft does. We'll see what they do. Yeah, this is a good thing because technology is moving forward. The transition times are always the most uncomfortable. Point being, we'll see what happens in the future. Okay, once OpenGL kind of goes the way of the dodo, we'll see what happens. We'll see what happens. Yeah. So a conversation for the future. You guys will be long gone by then, but this is something that I have to worry about because I'm going to be here still. All right. Other questions for this week's homework assignment? Yeah.
Kind of really got lost about centering the damn wheel.
Yeah, let's go over that again because that's important, right? All right, let's return to the setup tab, and we'll do it real fast. Okay, so centering things accurately can be a little bit of an issue. And excuse me for 1 minute while I just kind of reset my rig to a certain degree. There we go. All right. Okay, so I can see the center point for this item. That's not initially where it was. It was at the origin of the scene. Okay, I'm actually going to hit the 7 key so I can select the center point, and I'm simply going to hit in my setup tools to work plane position, which will automatically put that center point back at the origin. Okay. So what I want to do, and this is the intention, and whenever I'm rigging anything, I always think about the intention. Okay, what am I trying to achieve? I want that center point dead center in the wheel. I could do it by hand. I can get close, but Pat doesn't do close. I want it exact, right? Luckily for us, there's some geometry that will help us get exactly what I'm after, right? That's on that mesh item. So specifically, this wheel has a center line, okay? If there's ever a reason to have center lines on your geometry, this is it, okay? What I'm extrapolating here is that this is a circle. I've selected the center line for that circle. So the center point of that selection should be in the center of that circle, right? I want to move my center point for this item to the center of my selection. So it starts with the selection first. The work plane facilitates the movement of this thing way over here to this thing over here. Okay? If we go to the top of the screen and simply hit the work plane button, it's going to analyze what we have selected and place the center of the work plane in the center of whatever we have selected. Bloop. It's invisible. It doesn't do it, okay, in the setup tab. The work plane is there. It's always on, okay? And shoot, here's probably the best visualization of what's going on. See this little gray cube? That's the visual representation of the work plane in the compass, okay? Watch what happens when I move the work plane to the center of the selected edge loop. Okay? If you look very carefully, the work plane and our understanding of our 3 axes has been changed a little bit to match the orientation of what's been selected. Okay? That's what fundamentally is going on in the background. So now I can fire off my center point selection system, grab the center point that I want to change, and return to my setup tools. They're down here at the bottom. And we're going to set whatever it is that I have selected. In this case, it's the center point for my item to the work plane's position. And there it goes. I know it's hard to see, and I apologize if you're in the back, but now the center point for that item has been moved to what was the center of the selected edge loop. Okay? Absolutely. And I'm live streaming this, so if you can definitely go back in and see this in person once more. All right, so I'm going to hit undo. Let's walk through the entire sequence one more, okay? And remember the intention. I want the center point for this wheel to be in the center of the wheel, right? This edge loop here in the middle of the wheel is going to help. Okay, it's going to be like my little facilitator. Okay, so I've double-clicked on the edge, which grabs the entire edge loop. And then, clicking on the gigantic work plane button at the top is going to put the origin of our work plane in the center of that selected edge loop. What's the next step?
Just select the center point and also with it the whatever 6.
The pivot point, yeah. So if you hit the 7 key on your top row on your keyboard, it will go into the center point selection set. Okay. Now I can click on my center point. Okay. Click on my center point, and I want to tell it in my setup tools to be moved to the current location of the work plane, which just happens to be in the center of the wheel. Yoink, and there it goes. Okay. Okay. Melissa, what computer number are you? 6. Let's check it out. Now, which number are you hitting? The top row numbers? Okay. Let's see what's going on. Or not. Okay. So you're in edge mode, okay? Okay, so this is admittedly kind of wonky. This is weird, okay? You're in edge mode right now. Go into item mode next and select the wheel. That's polygons. Actually, what you had done, I didn't see that you had double clicked it. Click on polygons once more, and now you're in item mode. Select the wheel. Oh, you didn't separate the wheel out. You need to take. Yeah, it has to be. Yeah. That's the. Okay, here we go. All right, perfect, great. Now that we have the item selected, we can see its center point sitting down there at the origin, right? Hit 7. And now, did you hit 7? There it goes. And now click on that little white disc. Voila. Now you can move the center point. Okay. All right.
So once the pivot is in the middle of the wheel, what do you do?
I didn't quite hear that last part.
Once you put the pivot point in the middle of the wheel,
Yep.
what you do after that? What's after that?
So turn off the work plane. Turn off the work plane button. Okay. And then test it out. Just grab the wheel in item mode. Fire off the rotation tool. Now I already have this constrained to the revolve modifier, but I always do a little test. Is it kind of rotating the way I want it to rotate? Okay. If the answer to that question is no, figure out where you went wrong. Okay. If the answer to the question is yes, move on to the next step. All right. Other questions and comments? Yeah.
So you're saying that if you were to move your wheel right now, the catapult will move? Or is it just the catapult that will...
Yeah, other way around. So if I move the catapult, the wheel will move.
Okay.
I can't rotate this wheel along its x-axis anymore because that rotation channel, that animation channel is being controlled by the revolve modifier. See? So, that. Yeah.
You drag the master controller node out from somewhere on the right menu.
On the item list. I just dragged it from the item list, boom, right down into the schematic. Yeah, well, watch the live stream. It's on the live stream.
And live stream is located
Where can you find my live streams? My YouTube channel, which is Pat Crandley. Yeah. It really is that simple. Yeah.
So really quick, it'd be like on the wheel, we select the center edge.
Yep.
And then hit the the workplace button, and then hit 7,
You got it. Yep.
and then align to workplace.
You don't have to do that anymore. When you hit this button, okay, this button here,
Yes.
it's actually firing off the align well, let's get our terminology correct.
All right.
Okay. Because I think you were right, but
I might be a little
our
confusing.
terminology was just ever so
Off.
slightly off.
Yeah.
Okay. So. Okay, so I selected my item, hit the 7 key. I can grab my center point now. Okay, so it's the to work plane position button. To work plane position. That's what you're after.
And that's under, is that under the setup?
You got it right here under the setup collection of tools.
All right. To
To work plane position.
Thank
Yep.
you. To workplace. Jesus.
Plane.
Yeah.
Yeah.
Oh, it all corrected on me. That's
Let me
haha.
just end this real fast.